Can everyone see my screen?
Yep, all good.
Awesome. Well, thank you again. Hi, as Gleb said, my name is Emily Riederer, and today I'm here to talk about how we can create high quality and scalable data workflows for both the developer and the consumer side of the equations in large enterprises using column name contracts with dbt. To give a brief background on myself, I'm currently a senior manager at Capital One, and over my career, I've led teams focused on delivering a wide variety of data products, everything from analytics and models to core data infrastructure like data marts and dashboards. Today, I want to talk about the need for latent communication throughout the data stack to help data scale, and how column name contracts can help provide this sort of just-in-time context, and further, how these contracts can integrate with dbt and my own dbt plier package to build more scalable and resilient data pipelines. This work is largely inspired by my background working in large enterprises. While smaller and younger companies have relatively linear data pipelines, a lot of my career has been working in heavily matrix, complex environments and organizations. We generally have countless upstream and downstream systems and dependencies, and no one single data team, but many different data consumers and data producers. So it becomes critical to figure out how to scale communication about our data and couple the data's content with context about its provenance and how best to use it. Otherwise, you run into that classic situation where peer teams and users think data is wrong just because it doesn't meet the specific assumptions or use cases that they have that you may have never anticipated. Data contracts are a popular solution for handling this at the more technical level, but the best contracts don't fully meet the need if they are hidden away in documentation and YAML files that are only accessible by other tech teams. My team had the idea of using column names as that user interface to embed both the context and the contracts in a more user-facing way. To do this, we used the idea of a controlled vocabulary. Collaboratively with cross-functional partners, we can define stubs with different types of semantic meanings, reflecting data types, entities, and other details. Then these stubs are permuted to create a rich set of descriptive, intuitive, and consistent column names. And each component of the name can attach promises or contracts to the data. To make this a little bit more concrete, let's zoom in on a specific example in the type layer. Each stub can clarify common misconceptions about a type of data. So for example, for indicator variables, it can often be really confusing whether or not they encode that positive or the negative case is the 1 or the 0. But we can define the semantics of an int variable to always reflect the positive case. Beyond those simpler semantics, we can also attach more technical promises, like if a field is ever allowed to be null, or if it must be encoded in a certain format, like ISO 8601 for dates. Similarly with entities, we can use this sort of idea of a controlled vocabulary to get that alignment across larger and scaled organizations of what do we mean by these concepts that always trip us up, like what is a customer or what is a login. Define once, document once, use everywhere. This may all sound well and good, but of course, any promise is also a liability. Should our data ever break these promises, we're worse off than never having made them in the first place because we're essentially lying to all of our users. This is where a tool like dbt can come in handy to help us operationalize this approach at scale. In fact, I argue that column name contracts actually make it easier for data teams to dodge common failure modes like misspelled variable names or inconsistent encoding, because as we'll see in a minute, you can program against them so they improve both that user experience and also the developer workflow. Specifically in the back half of this talk, we'll touch on how dbt's Ginger templates, custom macros, and in-pipeline tests can all benefit from column name contracts. To further streamline this process, I'll briefly plug my own package, dbt plier, which is inspired by the syntactic sugar from the R package dplier. It basically functions to let you extract column names by pattern and apply the same transformations consistently to a set of variables. So, for example, we could retrieve all of the column names in an upstream reference dataset that start with ind. Next, for each ind variable, we can apply an average function to compute a proportion, but in just one line of code using the across macro. And similarly, we can dynamically create a where clause from a list of variable names. So how does dbt and this humble little pattern matching package help us scale column name contracts? First, consider the case of broken contracts. As an analyst, I used to find it so frustrating when a variable was named incorrectly or inconsistently, and my queries would fail simply because I failed to replicate an upstream typo. But Ginger templates can help enforce our consistent naming and definitions. By using the built-in control flow, we only have to write the logic once for many similar variables, like lags over different time periods, and deliver consistent results. Even worse than bad column names is incorrect field encoding. In my industry, precision of our results really matters. Often directionally correct isn't good enough. Early in my career, I learned I could never fully trust fields that purported to be dates or certain types of data types, because if they were actually timestamps or of an unexpected format, my date-based equality filters could exclude critical results. But with the magic of dbt and dbt prior, we can enforce contracts like data types systemically. We can find all of the variables named with a certain pattern and ensure that they're cast to the appropriate type. Of course, there are times when you shouldn't do this. We could apply the same type of logic to casting all n variables to integers. But what could go wrong here? If those variables truly aren't or shouldn't be integers, then casting them simply masks an upstream problem instead of solving it, which again, when we're ingesting data from so many different sources, could have a really negative ricochet effects. Not only do we have bad data, but we've now made it undetectable for everyone consuming that downstream. Luckily, dbt has a solution for this too. We can use similar logic with column name contracts to write in-pipeline tests. Building off the prior example, we could identify all of those n variables and run a test for each that they're sufficiently close to being integer-like before we do that final transformation. Not only does this help thoroughly test our data as it exists today, even better, it's a flexible and scalable approach, because if more variables are added later, our tests will dynamically adapt without more code needing to be added. So in conclusion, column name contracts can improve the user experience and developer workflow to help effectively scale data production and communication in complex data environments. Thank you.
Awesome. Thanks so much, Emily. Everyone, don't forget to take a quick poll that I posted about the usage of column naming guidelines and enforcing them. Emily, and by the way, if you have any questions to Emily, feel free to type them in the chat. We'll use a couple of minutes for some Q&A. Question I have, Emily, is how do you enforce these contracts for column names? Is it something that you do as part of like a CI process, so that if someone checks in the code and they have a really, screwed up the column name or the proper data type, that would be highlighted, or when one of those checks enforced and applied?
Yeah, definitely. And that's something you can do, I think, depending on the complexity of your architecture, either in a CI/CD process, like directly parsing the SQL, or even encoding that as part of your dbt checks. Once you've kind of run and rendered data in your dev schema, you can access all of the column names typically through, depending on the database you're using, an information schema. And I've even written these kind of tests for the validity of the fields themselves as dbt tests, kind of making sure that only allowed stubs are included, and those do have the expected data types. So many places you can plug it in kind of depending on the rest of your infrastructure.
That's awesome. It's really great to see how deep you went into defining the proper guidelines. I've actually never seen anything as thorough before. This is awesome.